And then here's not. Oh, wait, I don't know if the ones that
Plus or minus. You're taking the square root.
Okay. For number one, I'm going to ask everybody to imagine there's a whiteboard right in front of them. Take your marker finger and just show me what, from the bottom to the top, what sine inverse of x looks like. Okay, and if you were to continue that going upwards, you would make a nice
Sine graph.
sine graph. Is that how that worked? So in the x-axis, we need to go from, show me the numbers on the x-axis. Yeah, -1 to 1. And then the lower number is -π/2, and the higher number is π/2. And then I think you did something like this. Is this right? Something like that. Does this look like a line? I should make it a little bit more obvious. Thank you for keeping me honest here, like at this point. How about that? Is that a little bit better? Thank you. Okay. For cosine, could you do the same thing? I've got erase that whiteboard, and now go ahead and cosine inverse of x. Oh, nice. In this case, the x's are going from -1 to 1, and of course the y's are going from 1 to what? 0 to pi. And we have this, and something like this. Yeah? Okay. I need some help for number two, though. This is hard to do on the whiteboard in front of me. I don't think I'm going to make any sense of that. So, Chloe, could you help me out with this, please? Okay. And did you need a calculator for that? Good, thank you. Ooh, okay.
Pi/3.
Use a calculator for these. Is that how you got those?
Y value for either plus or minus u3/2.
Nice. Okay, so just here, 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 and here. Okay. Thank you. Any questions? Connor? Why would we have to do that? Yeah, this is a perfect answer if it says find all solutions between 0 and 2 pi, and it's exactly correct. But when it says to solve and it doesn't specify, the assumption is find all of them. Have you already done that? You found all of them?
No.
But you should just make sure that your neighbor has done it appropriately and efficiently.
You have to do the first two. Yeah. I think the first one. Five, three,
Okay, Chloe, do you want to make an adjustment to this, or do you want to call someone else? Okay, are we good with that? Adding 2 pi k to each one of them? Like if we're here and we add 2 pi k, we get back there. If we're here, we get 2 pi, add 2 pi k, you get back there, et cetera, et cetera. So that is acceptable. Yes. I see people with their hands up though. Haley, do you have anything to contribute here? What do you all think? Does that make sense? All right, so we hit both sides of that positive slope in one fell swoop, and 2 pi over 3 plus pi k. But either one is fine. Just this one is the most efficient. Max, you have a question or an answer? Yes.
You do plus pi over 3k.
Oh, can we do that? Good question. Can we just do pi plus? So just start with like pi over 3 and add pi over 3k?
Yeah. Yeah, pi over 3 would be pi.
Well, the distance to here is pi over 3. But the distance from here to here. Yeah. If this were another solution, I'd be totally on board. Does that make sense if we had those other ones that you could just say plus pi over 3k? But we don't have those. Got it separated into 2 different camps, unfortunately. But thanks, that's a good idea. Okay, moving on. Thank you for your help. Number 3. Nita, is this the same thing as what we just did? Oh, should I be a little sad? Okay. So what is this? Mhm. Okay. Positive pi over 3? Are we good with that? I should add like a plus 2 pi k or anything like that. Yeah, thank you. As we see from our graph here, there's just one answer. It's a single answer. So please don't add plus stuff when you're talking about inverse trig. Let's finish this up. Oh my goodness. Okay, for this one, it seems obvious to me. I just take this 2 out. Are you good with that? If you're good with that, I'm worried about you next Thursday. What's happening next Thursday? Oh, party, yeah.
Big what?
Pi party.
It's block 7.
I need.
Oh, it's the second of the day.
Whoa.
Yeah. Okay. Yeah, we can't just take a 2 out of here. I want some help. Who'd like to talk me through this one? Jonas, yes.
So if you want to use that property that we learned from math class, where basically sine of 2, you can consider cotangent of inverse of 12, negative 12 cents as theta, equal to theta.
Okay.
And then we can use that property of sine of 2 theta equals to 2 cosine, 5 times cosine theta.
2 sine.
Sine theta cosine.
Before we continue, are we comfortable with this equation? If you weren't here, it may be a problem for you, but for those of you who were here, hopefully you've
And then
practiced that enough.
you can solve for sine theta by saying that based on the cotangent, you can say that sine theta is negative 12 or 13.
Wait, where would that come from? I need help visualizing this. Where should I draw something?
Draw. No, not that.
That's the right triangle, for sure. Show me the number I'm looking for. What number am I looking for? Cotangent lives in
1 and 2.
1 and 2. Since it's negative, I'm looking for 2. I'm looking for that. So not just a right triangle. Now you don't have to do it this way, but I highly recommend you do this. And then we have our triangle, yeah. It's like a comedy routine, isn't it? Yeah. Okay, Jonas, help me out with this triangle. What were you saying about it?
You say that the x is equal to -12. That's the x over y.
Okay.
And then you can take a y equal to 5, also 5. And then from that, you can actually solve just for you can solve just for.
Nice.
And then you can just say sine of theta is 5, sine of 13.
So I'm gonna write this again. So it's sine of 2 theta is equal to 2 sine theta cosine theta. There's my theta. So you said that sine is equal to what? 5/13. And what do you guys think? Nicely done. Oh, and what's the final answer? 128, you said?
No, what?
120 over 169? Any questions? Oh. Yes, but not right now. He asked if we could do more, and the answer is yes, but not right now.
Not right now.
No, I'm sorry, you're gonna have to wait for it. I'll have lots of problems for you next Thursday. That is well, good question. Where does it come from?
What's it said?
Let's see. Oh, thank you. Okay. Jonas, thank you for not rejecting the gift I gave you. You guys know what I'm talking about? The 5 and the 12 was a gift, wasn't it? Oh, yeah. Yeah. What would rejecting that gift look like? Yeah. Doing this would be rejecting my gift. I don't want your gift. I'm gonna make my own gift. We take a moment and just discuss all the Pythagorean triples that you and your partner remember. Is that you, Simran? Is that you?
No, not smile.
It's gotta be ended.
Oh, that's what you mean, okay.
Okay, so we have 5, 12, 13, also 3, 4, 5. Ooh, 3, 4, 5. What was that? 8, 8, 5, 17. Is 8, 5, 17 even a triangle? Why is that an impossible triangle? 8 plus 5 is less than 17. Yeah, it's not even a triangle. 8, 15, 17 is a triangle. Okay, what's yours? And 7, 24, 25. I'm gonna put this up here. I'm gonna move this. How do you guys remember 9, 40, 41?
Oh my gosh, I gotta tell you this. Oh, Mr.
Is it very short?
It was like 9:40. And I was just thinking about the triplets and then I came across.
You like it was 9:40
But
the
now I
time?
just remember that it's triplet, like.
Okay. Okay.
You just gotta-
Interesting.
I'm just always on the balls of my toes.
I appreciate that. I
I'm
appreciate
ready
it.
to like,
Pounce.
I'm
Ready to
ready
move.
to like, in a freaking like a little like bush. I'm ready to sneak up on Matt.
We see that. Sneak up on that. You get an A for that one. I like it. Yeah, I think that these are the main ones. I think you definitely be familiar with these. 3, 4, 5. Yeah. Oh yeah, 3, 4, 5. 3, 4, 5. Yeah, I identify as 3, 4, 5. I can see that.
You're in junior year, you're gonna get like.
Just a really quick bit of trivia. Quiet down, please. Quiet down.
Wait,
Quick bit of trivia. When the number, you see that I've grouped it together such that the last two numbers are consecutive.
Oh,
It's usually that way for the triples, which is kind of interesting. One of my students from the last period, Jake, do you guys know Jake Barr?
no.
Yes.
He told me some interesting thing that his dad told him. If you square this 49, like square this 7, you get 49, and then double this, it's one less than that double. And if you square this 5, you get 25, which is one less than 26. If you double this, you get 9, which is one less than 10. I don't know if it always works, but if you square that,
I like Jake Parr.
isn't that interesting? And his dad, I didn't know where that came from. I think we can make this one apart. Would it still work here if I made this like 4, 7.5, 8.5? Would it work here?
Oh, it does.
Does it still work?
It does.
Let's see, if you square this, you get 16 versus double this was 17. One less than that. Oh. So if we kind of force that to be one apart, that's interesting. Oh, I don't know. Well, it only works when these two apparently are one apart. Like it didn't work for this one. It didn't work for that one. So the pattern works when those last two are one apart. Which is interesting. I love that. Yes, all of them.
7 is a special number because it's the only number that's in 2 permutations.
Oh, not 5? 5 is also special.
5 is on by.
Yeah. But 5 and 7 are both prime. That's good. Maybe that's what they call prime numbers. Maybe not. Okay. You guys ready to move on? Our last lesson? I think Kayla's ready. I'm not sure about Simran.
I'm ready like this. I was ready.
Simran has given the posture that
Back.
yes, she is ready. I'm gonna tell you right now. I'm about to break your math. About to break it. Don't be sad. Be excited. Kind of okay, but with this, should be. Let me give you a preview about what's to happen. What's to come. So up until now, probably since when did you start graphing? 4th grade? Too young. Oh.
I graphed my success and effect.
Oh, I did a t-shirt that says that.
What about the choreograph?
4th grade, yeah. I started 5th grade. Up until now, to get to that point, you always begin at the origin and then move along the x-axis and then go up the y-axis, right? It's always been like this. And it could be a z-axis, exactly. Do you know where the z-axis is? 3D coming at you, yes. You're like a t-shirt maker now. Okay, so what we're gonna do is we are going to make it more efficient. We're not gonna go to the right when it's up there. To get to that point for today, what we're gonna do is just go right to it. This is gonna graph it, which means we need 2 bits of information. We need to know, first of all, how far we're going, which we're gonna call R, and one other bit of information, which is called,
Terminus.
you know. Oh, don't take notes right now. It's about to come out. But what is the other bit of information you need to get to that point as opposed to one that's up here about the same distance? The angle. Does that make sense? With this bit of information, you can get that same point? Yes. So what this is called polar coordinates as opposed to what we've been doing. What kind of coordinates is it? It's X and Y, do you know? Non-polar, one way of saying it, or rectangular, or
Cardioid.
Oh, cartelian.
Cardio.
You said it like you really knew.
Cardioid.
Cartesian. Have you heard of that? Cartesian coordinates? Yeah, Cartesian plane. Because it's X and Y
Descartes.
from
Oh.
Rene Descartes. Rene Descartes. Okay, so let's go to the actual packet today.
I think before I land, I'll take off.
Great.
There we go.
I'll never
See that point? We get there with R and theta. Notice the ordered pair is no longer X's and Y's, it's R comma theta. R just represents the distance from. We'll talk about that in a moment. You don't have to read all of that. What I want you to do though is you and your neighbor go ahead and with what you know already, see if you could graph these 4 points. Oh, this is the last section. What page is it?
Yeah.
28.
Never can believe this.
I'm gonna think of, I'm gonna think of.
Yeah.
Two.
Oh my God.
That's
That's the last page.
But I'm actually so, thank you.
One.
Miss Julie, can I, in the last, did they get to the whole?
Wait, right?
No, we.
Oh, this is probably polar grid, by the way. That's a polar grid, that makes sense. Direction and distance. It's both of those Cartesian axes. I'm gonna call 4 people. For A, I'd like Kayla. Whenever you're ready. Kayla. For B, I'd like it can't be Augie, unfortunately. It could be Simran. For B, oh, Leah for C, and Miley for D. So without me saying anything else, I want to see if you can put this together. So Kayla A, Simran, Leah, and Miley.
Well, like, not today. I was doing it today. Wait, you just practically listen. Yeah. If this is gonna be on the side, then don't leave us a unit. Wow.
So call 4 people up whenever you're ready. Come on up. Oh, these made sense.
Yeah.
Okay.
Environmental science.
Oh, mine too.
That's great. You have a few buckets. Okay, does your answer match those on the board?
Yes.
Nice.
It's really fun.
I think so too. I think the difficulty is people see that B and they say, should that be -1? Well, it would be -1 if we're on the Cartesian coordinates. Sorry, graphing rectangular back with polar. That is positive one down, or positive two. Positive one. Any questions about that? Perhaps your question is,
Can we do some more?
can we do some more? Well, the answer is yes. Swish. Yeah, go ahead and do the next four, please.
X.
And don't call it any answers, but you may discuss crowd with your neighbor when you figured out what's going on here. And don't call anything out. You got them all. Okay. Discuss with your neighbor if you haven't already. I'm about to call on someone in just 10 seconds or so. So I'd like to hear only from the one and only Oliver. What do you notice about A, B, and C? They're all at pi over 4?
Yeah. On the two, and then I.
Okay. So they're all the same point. Do we agree that the first two had the same point?
Yeah.
Just different names. Let's talk about D also for sure. Yeah, so what's one thing that's interesting about polar coordinates is that there are multiple names for any particular point. Like in this case, there's at least 3. But let's talk what's going on about D. And in order to do this, I have to tell you about some of the basics of polar coordinates. You know, for rectangular coordinates, how many axes are there?
2.
Normally just 2, just the x-axis and the y-axis. Also, where the axes meet is called the origin. For polar coordinates, do you have any idea how many axes there are? I think it's 4. There's 1. There's just one axis. And that axis rotates. Oh. It rotates about something called, the origin is for rectangular. In polar, it's called the center. Good guess. There's one at the north, one at the south of this pole. It rotates around a pole. That's why they're called polar coordinates. So when you do these, what you think of is here's our axis, and it is rotating about that pole. So for D, if we want to figure out where negative 2, 5 pi over 4 is, I'm going to point in the direction of 5 pi over 4, which I believe is over here. Is that right?
No.
Or did I just accidentally do 7 pi over 4? Oh my goodness. Something like that?
Yeah.
Okay, so we know that right here would be 1, right here would be 2, here is 3. So where would negative 2 be? Would you please discuss with your neighbor? Where is negative 2?
The opposite direction.
That is tricky.
Hold your going just back. So the negative numbers doesn't make sense. It just goes the other direction. I like to think about because it's going out the back. So I'm going to continue this way. So we're actually going right there. So that is, well, the axis still continues, but notice that on the axis we have 0. This is now negative 1, negative 2, negative 3. It's a full axis that rotates. It has positive numbers and negative numbers. Just where is the orientation is what's different. 1 and then 2. Yes, Matthew.
So when we have one of these problems, we start at like, yeah. You start at zero and we count it normally,
Mhm.
and then you just go to the other side.
Perfect. Yeah, exactly.
Uh,
Over the what? Oh, I don't think there's an origin here. Though. Over the pole. The pole, yeah.
There's a. Wait, what if it was a negative y?
Y value? Well, that'd be rectangular. We have R and theta here. So we've had negative, like B is negative, isn't it?
Yeah, oh wait, I get that.
Yeah. Yeah, so I think you already know. Yeah, you have a question?
So like 1, 2, 3, and then like you go backwards the other way, like on the normal, just like side to side, like -2, and then
When you say side to side, I'm sorry, what do you mean?
if on like the marked at like originally, like the 1, 2, 3, and then if you go like backwards, it'll go like -1, -2, and then you go like forwards, like.
Whoa. It seems like you might be overcomplicating. There's one axis. I don't want you to always reference that horizontal one. It's just one that's rotating. Just let it change your perspective, which is what I mean about breaking your math. Don't try to hang on to X and Y. Oh, for sure. There's only one axis, and the theta points it in a particular direction. In that direction, we have positive numbers, 1, 2, 3. But this axis, just like any axis is infinitely long in both directions. So if the positive numbers are this direction, the negative number is going to be the opposite of those positive numbers.
How do you know those are positive?
Because it says the point in the direction of 9 pi over 4. I'm sorry, of 5 pi over 4. So that's the orientation. Going this way, those all of them are positive, which means the other ones have to be negative. Any other questions? Are you enjoying this new view?
This didn't break my mind at all.
No?
I feel so, okay, you know what it is?
You're already
It's like-
broken.
It's like, I'm like that leopard that came out of, but now I'm walking around my prey. Prey doesn't even know. Prey doesn't even, so I'm just sitting there chilling.
Thank you. Good stuff. Okay, here you go. I like that, Max. Thank you. Oh, nice.
Thank you. Okay.
I will be calling on select individuals for this one momentarily.
Oh.
Oliver, did I answer your question earlier? Be calling someone in about 12 and a half seconds, so please make sure to have answers ready. Eight, 9, 10, 11, 12. Lee! Can you get us one answer here?
I got.
Do we agree with this? Let's see, so 3, 5, 5, 6. I think that's over. I like that reason. So do you see that if you point at 11 pi over 6, then you have to go -3 to get there? What do you think, Chief? Does that make sense? That makes sense. I'd like to hear another one from the one and only Una. -3. Ah. Is this Valid? Yeah.
Oh, yeah.
Perfect, thank you. Who'd like to give us another one? Maximilian.
-3, comma, 149.5 for this one. I would say that's valid.
It might be right, I don't know. I'm gonna check out 149 pi.
That rational function on the bottom.
Maybe.
Oh, wait, no, +3.
Oh, +3, thank you, okay.
That.
Oh,
Spelled
okay,
it.
okay. Spelled.
We
Still
all
positive.
walk through mud, get to the eventual.
Namaste. Yes,
I'll donate.
Common negative pi
negative what?
are 7 pi.
Does that work?
Yeah.
Does that make sense, everybody? Thank you for not having a crazy answer. But I do like the answer, Max, thank you. One more, anyone want to share with us a different one that they got? There's infinitely many, yeah. Oliver, you have another one?
pi/2, comma, -2 pi/3.
Wait, oh, are you doing X's? Are you doing Cartesian? 2 pi/2.
I've got it here, like.
Because I don't have a, I'm looking,
Wait, I'll keep 0.
oh, 0?
No pi on them.
0?
I meant.
I think I think you might have gone on to the next one. But yeah, for that one, it's got to be either 3 or -3 and either pointing that direction or opposite from it. But any one of those are fine. I don't think 0 could be one though. Any questions? Okay, let's go back to well, I'm gonna go back to the warm-up where we could write would be great. Okay, so I'm going back to just this definition. You can copy this down somewhere. So I've made a triangle. The other sides of this triangle, I'm gonna label as X and Y. You see which one's gonna be X, of course. And this one is Y. So first thing I want to do is get some formulas going from polar to rectangular, which means I have R and theta and I want to get X. So if I have R, theta, and X, what relationship, the whole mathematical relationship, to put these three together?
Oh, there.
We'll check with your neighbor. What relationship puts these three quantities together?
This side.
So these three, what am I looking for? Basically, X, R, theta, and X are bound together by cosine, right? So I just a little side work here. I'll say cosine of theta is equal to X over R, and from this we have X is equal to R cosine theta. That's our first conversion. Does that look familiar that X is equal to R cosine theta? Have you seen that before? In unit circle, that's a very specific example because in that case R is 1. And if we get larger than that, X equals R cosine theta. And if we have R and theta and we want to get to Y, the relationship between the three of those would be, of course, sine. So we know that sine of theta is equal to Y over R. So Y is equal to R sine theta. Have you seen that before? Yeah, this should be nothing new for you. R sine theta. Yes. Oh, yeah, what does P mean? Polar, and R is for rectangular. Yeah, that's why I was going from the R and theta from polar to rectangular to the X and the Y. So you don't always have to use these, but this will always be true. Let's do some examples. From the packet, back to the packet. Here are 3 coordinates. What kind of coordinates are these?
Polar force.
Are you sure they're polar? And how do we know?
Well, because it says so.
Because it says so.
You know,
And it's a pretty good hint that the theta includes pi. So I want you to find x and y for all three of these points. Change these to rectangular.
Why all the. Is it with the X side?
But it's so good. From polar to rectangular.
Just look at any.
I mean, if you look at this. That's a direction more than anything else. That's a theta. That's a direction. That's a direction. Our common theta.
I can never be honest with.
Oh, I got it. What did I do? They want to ask me what I would do. Like, I don't know. Guess not. I can't believe you guys got excited. Typical plastic. Typical plastic. Oh my God,
Or are the X side and the, yeah, this is just our.
Is anyone finished?
Yeah.
Still lost. Yeah, so thanks.
Can we proceed?
We could.
You did working well with you. Haley, get with that. What you do?
Yeah, so I wrote out, formula.
Okay. Okay. Nice. And then for why? Any questions about that? Is there another way to do it? That's a perfect way to do it. But also, like, how about you just graph the point 2 comma theta? Sorry, 2 comma pi. And where is that? Like, graph it in your head. 2 comma pi, isn't it right here? Don't we already know that's -2, 0 in rectangular? Right, so you could get there in polar by pointing there and then going 2 in that direction. Or rectangular, just go there in the x-axis, -2, and then don't go up or down. It's the same thing. Yeah, it'll always work. But the formulas will always give you a sure answer as long as you don't make any mistakes. So perfectly done. What's that? Is it okay? -20? Okay, for B, Judy, help us out here. Are you sure it's cosine? Okay. And then what happens from there? Okay, because cosine of 5 pi over 3 is 1/2, so that's 2. Okay, and for y? Okay. And when you work through that? -2√3. Are we good with that? Yeah, why is it negative? So Judy, where did that negative come from? Yeah, sine 5 pi over 3 is negative √3/2. That's in that fourth problem, so. Nice, is it? Is there another way to do that problem? But let's graph it. I want to check this out. -5 pi over 3 means we are right here, right? And then 4 means it's right here. Is there a way to get that x and y value without those equations? Hey, is this 3, 4, 5? No. Is it 36 to 90? Is it 36 to 90? How do we know it's 36 to 90 now? I guess 5 pi over 3. So, like, going this way in standard position is what, -pi/6, which is the same thing as negatives. Sorry, over 3. -60, or yeah, it's a 60-degree angle right there. You please check with your neighbor to see if they remember the other sides if that hypotenuse is 4 for 36 to 90. Okay, so from that hypotenuse, we get the which leg? Which leg do we go with it to from there? Short leg. Did your geometry teacher tell you not to say short leg and long leg? Say like the angle opposite this, the angle opposite that. Oh, I know. Oh wow. I've been on. Yeah. Short leg, yeah, I'm a big fan of short leg. Short leg is always half of the hypotenuse, that's why that's 2. The long leg is always short leg times √3. That's why that is √3, and that's how we get immediately to our 2 comma -2 √3. And if you have any angle that's on the unit circle, you should be able to do that. This is either 36 to 90 triangle or 45, 45, 90. But that's all from the unit circle. If you have pi over 5, definitely use those equations and get your calculator out. See, let's see what you did. Jonas, you just tell us your answer there, here.
Uh,
3 √3/2. And what? And 3/2. Let's see if this works out. Did you use the equations to get there?
I did, but I didn't like. I'm like.
Nice. Oh, so you rewrote it from going this direction to going this direction. Does that make sense, folks? So just rewrite it? Like analyze what it is. Because that's just another name for it. So everything's positive there. That's really nice. Thank you. I think you could do it from there. Or do you see how you could use the special right triangle from there? We get the 3, the short leg, which is 3 over 2, and then the long leg is just that times square root of 3. 3 root 3 over 2. So you get the same thing. But I really like how you renamed it. I think that was clever. But it works out regardless if you don't rename it or if you do. If you rename it wrong, that's the problem. Okay, any questions about what we've done here? And Shiv, I'm sorry. There isn't another one of these. We're moving on to another topic. The last topic. We're about to graph a number you haven't never graphed before. Complex. Oh gosh, I didn't do this yet. Converting from rectangular to polar. Shiv, you're in luck. There's more. We're gonna graph complex numbers soon. I'm going back to the warm-up. Well, my warm-up. Yeah, the notes I was just doing. If we want to go from rectangular to polar, I completely forgot. Oh my goodness. Which means we have x's and y's, and we're trying to get r and theta. So if I have x and y, what's the relationship between x, y, and r? Yeah, I'll say r squared equals x squared plus y squared. Okay, so there's one relationship. How about the relationship between x, y, and theta? What's the relationship there? Tan theta equals y over x. So this is to go from rectangular to polar. Notice rectangular on the right side, rectangular on the left side. Okay, back to the packet. I'll let you copy that. But it is in the packet also. It is right here. Okay, so we're back to rectangular lab. Please change these to polar. Okay, I'm gonna go ahead and go over a couple of these. Or maybe this is x and y. If I want r squared, so if I want r, I'll just do this. Say 2 squared plus 2 squared. What is this? 8? So r equals positive or negative? Could r be negative? No. Really? Polar coordinates r can't be negative? It can't. I would put plus or minus 2 to 2. So that's the r. I still need to get theta. So to do that, I'll say tan theta equals 2 over negative 2. Or tan theta equals negative 1. What does theta equal? Yeah, same. 3 pi over 4, or wait, or what? 5 pi over 4? 7 pi over 4? But let's say 3 pi over 4. Are we on board with that one? 3 pi over 4? Well, what is tangent of 3 pi over 4?
Oh.
And we can think about it as a slope. But we could also have plus pi k, right? So how do we choose r and choose theta if there's two options for r and infinitely many for theta? Well, go ahead and discuss with the neighbor. How do you get r and theta from these? Because I want the coordinates.
Wait, why does of course, and does not equal negative one, so find five without negative one, two.
Okay, 5 seconds so we get the answer. Connor, you had your hand up earlier. Can you help us out with this one?
Well, you know that. That is, that project,
Mhm.
so. There's a multitude of combinations that could work.
Okay, nicely said.
Something that we're looking for the simplest, then you can do. Through to. How much we hire for, is that, it's 3 power 4 and then.
Yeah, we're pointing in that direction and we're going to that direction. Thank you. Simran?
And it's gonna be R comma theta, wait. Yeah,
Yes,
here is theta comma.
that's always r comma theta. If polar is always r comma theta, but for Cartesian, it's always x comma y. Could we have chosen -2√2? Would that be okay? That's fine. Discuss with neighbor. What would the theta have to be? So what Connor chose was to go in that direction. But we can also, if it's going to be negative, that means we have to go in this direction to get there. This direction towards, what would I call that? For the direction of theta. Either -5/4 or 7/4. There's multiple methods, multiple names for that. So you could choose that negative part, but you just have to make sure to accommodate it with an appropriate theta. So be careful because we're going to have an infinite number of possibilities and you must choose one that is correct. So be that in the box. Then by the knowledge of direction and positive just kidding. Yeah, just unless otherwise you can set by 3 possibilities. And you could use equations for P and C as well, but do we have to? Like 1 comma -3, I'm gonna adjust this a little bit. 1 -√3, excuse me. I make a triangle here. Is this a special triangle? That √3 is very suspect. This is just a 2, isn't it? Because the long leg is 1 times √3, so that's definitely a 3690. So I could already get my polar coordinates by filling it in. 2 comma. What? Degrees are okay. Is it 60 degrees? Is that -60. Or what? 2/3. We could do 2/3, can't we? Yeah, 2/3 would be fine if we do negative. Say that one more time. Yeah, exactly. I think you got it. Yeah. And 0, -5? That's down here, isn't it? Do we really need equations to get polar coordinates? Is it? Does he speak the truth? 3, 5, and 2? 3, 5, or 2. And the R is which I think is what we would get the equations. -3 pi over 2? Oh, here's the C. A double flip. Yeah, okay. Excellent. Okay. Last thing, a quick introduction. I said this is so fast, but we have to talk about complex numbers. Until now, we have not graphed complex numbers. Today, graph them. What's that? They've been holes in graphs, exactly. So, this number, 3 plus 2i is a complex number, is represented by this point. Because what we have is one axis is real, the other axis is imaginary. So this, I'm going to put an I. When you graph 3 plus 2i, it's the same thing as going to 3. Same as splitting. Yes. So like if I want you to graph the number -1 minus 3i, would that be difficult? What's a complex number? No, this is a complex number. So -1 minus 3i would mean on the complex plane, we go to -1 and down here. Now that is a single number represented in 2 different dimensions. We introduce the imaginary. Good question. It's hard to wrap your head around that for sure. I'm not sure there's a way to say anything else. Like say, oh. So, yes, Simran? Yes. I wouldn't say slope, but it's yes, in order of events. So if you do the real part, it's horizontal, and then the imaginary part, it's vertical. Anything I have good. Yes. Exactly. Yes. Yes, that's why I tucked an I up there, I guess. That's the imaginary axis. It's a coefficient of the imaginary. That's nicely said. So there is a rectangular form, but this could also be written in polar form. So if you think about this as x plus yi, then I'm going to bring in exactly what we talked about before, that x is equal to r cosine theta, and y is equal to r sine theta, I'll put this. That would just be the polar form, in which case we need to find r and theta from x and y. And so there's a rectangular form and there's a polar form. So I think we have just enough time to get through these examples. Example 6, complex number is represented by a point in the complex plane. Complex number has a rectangular coordinates, -2, -2. Okay. So that would be -2 plus 2i. Oh, thank you, -2i. Ooh, good catch. That's negative. Okay, so how can I get my r and my theta? Yeah. We have x and y. We're in rectangular. We have to revert to polar. Well, this is rectangle. So I'm gonna do little bit of analysis on the side. I have my -2 over here, -2 on the side. Do you know what my R is? It's +2 or 2 if we're pointing that direction. And do I know my theta there? Either -135. I need to keep it positive. 180, what, 225? There's my R and theta. So x could be changed to 2√2 times cosine of 225 degrees minus 2√2 sine of 225. I think the I comes first, doesn't it? Approaching this. Oh, because someone said degrees, Connie said degrees, so I'm like, I was living, it could be radians too. I think degree in radians that would be 5/4. Just did that in your head? Incredible. In this case, it's represented in polar, and I should write here polar form. This is polar right here. Okay, so if this is polar, then I know that R is 4 and theta is 7/6. Can we change the x and y with that? Sure. X is equal to, oh, I'm not going to use equations, I'll just do it. Done. So what I'm looking at is -2√3 plus, nope, not plus, -2i. That's that vertical is imaginary. That was a ton of stuff today. I'm sorry to taxing last. Yeah, that last bit, last thing on a Friday. Have a great weekend, folks. I'll see you on Tuesday. I'll email you about the homework. I'm not sure if it's going to be Pearson or the packet yet.